Welcome you all to the video lecture of computer organization and microprocessor. So here in this video lecture we are going to discuss the module topic related to that of our computer organization and microprocessor. So here in this video lecture we are going to see to the topic related to the functional units of a computer. So here this functional unit of a computer related to that of major three sub-blocks such as this I/O devices, input and output unit, main memory, primary and the secondary memory, and the processor. So the processor is a combination of the ALU, arithmetic logic unit, and the control unit. So now this input and output units will accept the coded things, which means that the information coming over to our of keyboard, scanner, mouses in the input unit. So automatically we can able to get restored to that, which means that the input unit will says to the top the accept coded information from where this keyboard, mouse, and the scanner. So here this input units will convert those things into a binary one for our processing things is in the processor. So here the main memory says to offer two subdivisions such as the primary memory and the secondary memory. So the primary memory related to that of our random access memory and the ROM memory. So random access memory and the read-only memory. So these two memories will be categorized according to the top two things such as volatile and non-volatile things, and automatically this cache memory will comes under over this RAM memory. So the primary memory has what? The RAM and ROM. So under the RAM, the cache memory will also be get stored over in this primary memory. The secondary memory will say is what? The secondary memory such as the our external hard disk, SSD hard disk. So these are the things is where comes under in this secondary memory. So the next thing across this processor is the ALU. So the ALU is nothing that the arithmetic logic unit, which will perform the basic arithmetic functions such as addition, subtraction, division, and multiplication. So these things will be taken over in this arithmetic logic units. So with the help of our which signals is binary signals from the input unit. So whenever we are giving a binary information through our input unit, that will goes to this main memory. So after checking over into that main memory, this arithmetic logic unit, which means that in the processor it will get the information from the memory. So this arithmetic logic unit will perform according to that. So the next things we need to going to see is the control unit. Here this control unit majorly does what? It will fetches, decodes, and execute what are the instructions has been mentioned over in the processor, which means that generating the timely and the control signals. So this will comes under in the topic for the control unit. So the final thing in the functionality of a computer is the output unit. Here this output unit will sense the processed information or process result to the outside world through help of the output devices such as monitor, printer, and speaker. So this is the first part comes under into the topic of the functional units of a computer. Continuously we are going to see regarding to the evolution of the microprocessor. Here this microprocessor's evolution has been categorized into five subdivisions, which means that five generations from 1971 to 75, after 74, which means that mid 1970s, and across the year of 1980, after 1990, and 2000 plus. So with respect to these year segregation, the processor evolution has been given over here. First, in this first generation, they were using the 4 or 8-bit generation modules, which means that this processor will perform as real-time example to the top of calculators and early PCs where the things has come under in this first generation of the microprocessor. So the second generation, the evolution from the first generation, here the 16-bit architecture processor has been introduced, which means that the first processor is the comes under in the 16-bit is an IBM processor. The next generation, which means that the Intel processor, core processor 8085, 8086 based processor has been introduced here with the performance of doing the multitasking things and the virtual memory. So the next one is the fourth generation of the microprocessor will do the superscalar functionalities and multimedia functionalities with the multitasking options. So these things is the additional to that of third generation processor. Here this fourth generation will do the process. Here the best example is the Pentium and AMD processor. So the fifth generation is our current generation based processor, such as Core i3, i5, i7, and the current generations Ultra 5 and Ultra 7 and i9 processor and workstation processor. Here the additional things are such as the AMD Ryzen model has been increased, the ARM processor M1 and M2. This ARM processor M1 and M2 will come under in the iOS device products. This AMD Ryzen and the core comes under in the Intel processor. So here this evolution of the microprocessor basically segregated in with respect to the 5 generations: first, second, third, fourth, and fifth, with respect to the year of 1971 to 74. After 1975, and third generation deals with 1980, fourth generation deals with 1990, and the fifth generation deals with the 2000 years. So according to our prescribed reference book, this the migration, which means that introduction of next generation of processor says us that the transistor counts will get double with respect to that of migration of from one processor to another processor. So this transistor counts get additions, it will gives a better results, which means that of exponential growth in the performance, memory capacity, and energy efficiency. So normally we can say that the transistors enhancement leads gives the better performance to the current generation microprocessor. So the next topic related to this is the basic processor architecture. Here in this basic processor architecture, it includes the PC, IR, and R0 to Rn-1. So here this PC is nothing that the program counter, IR is nothing that the instruction registers, R0 to Rn-1 says to the top of general purpose registers. So here this processor is also get interconnected with water. In the first slide we say that the ALU and the control unit. So in this thing, which means that in this processor only these PC, IR, and the general purpose registers are get interlinked over there. So here this processor will automatically do the functionality of interfacing the main memory and the processor and do all the process with respect to our given instructions. So this simply we can say this program counter says as what it will holds the address of the next instruction giving to the top in the command prompt, whereas the instruction register IR gives us the current instruction where it is being executed, how its output will get derives through the control units, which means that control circuit to get generate signals. So upcoming this general purpose register says as what high storage element to get for the operands and intermediate results in order to get avoid the repeated memory accesses. So in this video session, we see the functional units of a computer. In that we also saw regarding to the evolution of microprocessor and the basic processor architecture. Thank you.